Current saturation. There is a maximum available current that can be drawn out of the op amp. But this is true for any device. And to give you a sense of what I'm talking about, let me start off with an analogy. And this analogy, suppose we have a circuit that looks like this. So I have a power supply, and there is a decade resistor box. In this case, we're just going to say that our load resistor is then going to be a variable resistor. So we can change it to whatever value we'd like. So what we're going to do is that we're going to measure this current here. So when I measure this current, this is going to be the current of the resistor here. Our lab power supply or supplies can put out a maximum of 500 milliamps or half an amp. So one could imagine here as the resistor value of the decade resistor box is continuously reduced. The demand on the power supply to output more and more current will reach a limit. I mean, one very, very simple example here. So even so, even if our load goes to zero, right? In other words, if I take this and I take my load resistor, and as it approaches a very small value, then we're expecting that in this situation, that current should then approach infinity. But of course, that's crazy. A power supply cannot put out, that amount of current. So the power supply cannot output more than 500 milliamps. This is a limitation of the power supply. So now the same thing happens with the op amp. Okay, so if I come over here and I'm going to say that the same type of situation also occurs with the op amp. There is a maximum available current that can be drawn so that the op amp acts linear. So the way we typically draw this thing is that we do the following thing. So I'm looking at my inputs. Right, so this is going to be V1. This is going to be V2. So when I'm thinking about the current, I'm seeing that this is the out. And typically, the way they define the current here is that we're really, they typically say that the current flows in, but for this situation, I'm going to say that we're trying to pull out more current out in this direction. So if I out is too large, the op amp stops behaving linearly. And cannot follow V out equal to A V in. The op amp is said to be current saturated. So in summary, if I look at the current of I out, and if it's less than I saturation, and this saturation is somewhere between 20 to 40 milliamps for the 741, it behaves linearly. On the other hand, if if I out is greater than I saturation, it does not behave linear. And that's what we showed in the lab.